So it's coding time.
I've got the web services running on the Raspberry Pi, so I can do things like query the history, turn on and off relays, check on my settings, update my settings. So I need to put a nice UI around that to manage the whole thing. For that, I'm going to use Angular. I haven't done any Angular for a couple of years, so this is going to be kind of exciting for me too, remembering all the bits I've forgotten. And I'm going to make this as lightweight as possible. My previous Angular applications were using all sorts of back-end services like Firebase and authentication and things. So because this is just going to run in my home network and I don't need all those things, I'm just going to make a very simple, lightweight Angular application. I think I'm ready to go. Let's try this. Okay, here's my design for the SolarUI. That's going to be the Angular application. I'm going to keep it simple, so I'm really just thinking of a 3-tab interface. This sort of represents what's going to be on the 3 tabs. It's going to be no routing, so that's something else I don't need to include in the Angular application, just make it a bit more lightweight. So the first tab, like I show here, is going to be for the Renogy solar controller, so it's going to be showing things like the history graphs. I'll probably have some buttons or something to select between 24-hour, 1 week, 1 month, 1 year view of the Renogy history. Also on here, I'll need some sort of button to be able to turn the webcam on and off. And as well, I'll just show the latest status information coming off the Renogy controller. So things like current load, current power being generated by the solar panels and things. So just show those stats down the bottom. Next tab is going to be for the rig or the ham radio, and this is going to be tied into putting together the CAT interface, so the computer interface to the ham radio. So some of the things I know I need is, again, probably some sort of button to be able to turn the ham radio on and off using the relay. Then a series of controls to set the ham radio to different settings, so things like setting the frequency, setting the band, those sort of things. And then I'll probably put a big push to talk button on here as well to switch between transmitting and receiving. So that should be the rig. And then finally under settings, settings is the settings that you find in Solar Cache JSON file. So things like what's the minimum battery level before more aggressive power saving settings go in, how long should the webcam stay on when I force it on, how long should the rig stay on when I force it on, whether the webcam stays on overnight, and also if I manually turn off the webcam at a certain hour. Those are all settings at the moment, so they'll become candidates for the settings tab to be able to change those around. So that's the plan. So let's try putting this together in Angular. So I'm going to set up my basic Angular development environment for SolarUI. And this won't be an Angular tutorial. I'll just cover the main things that are relevant to the project that I'm doing. So I'm in my projects directory. That's where I put all my Angular projects. And I'm going to do a ng, which is the Angular CLI. New in the name of the project. So they'll create a new project for me under projects. I'm going to say no to routing. That'll save a bit of the size of it when I make the distribution, and I'm going to use SCSS style sheets. I've opened that folder in Visual Studio Code, so we can see my Angular application here. Under source, I just want to check under app, and I've got no routing module, so that's good. Everything's being created the way I'd expect. So the first thing I want to do is add in Angular material, so I can add some bling to the front end. I'm going to go with purple green. We can change it. Oh, actually, I'm going to change to deep purple amber. Sounds like a good color version. And yep, I'm going to have all the animations. So I'll let this install. And the other thing I know I'm going to use is Google Charts to do all the charting. So I'll use npm to install those. It's good. So I'm just going to do a ng serve just to make sure everything's working as is. It's basically going to fire up the boilerplate code that's in the basic project. Okay, that looks good, and let's just check on the web browser. That looks good too. Okay, let's just do a bit of housekeeping. So first I'll save my changes to my local Git repository. And I'm going to publish this up to my GitHub. And it's going to be a new repository. I'll make it public, and I'll put the link down in the description below. So that's good. That's going to sync all my changes up to GitHub. Let's have a look. Okay, we can see it all here. First thing I'm going to do is to set up the architecture for the tabs. So I'm going to go into app module, add the import of material tabs, and edit into the imports as well. Looks good. Save that, bop over to the app component, and in here I've just added some basic tab code, so it should show some tabs. Let's save that, and let's try running this. Okay, and there we see our 3 tabs ready to go with a bit of content under each one. So at the moment I've just got text in as the content, but I'm going to change that over to being Angular components for each of these 3 pieces of content, and we can work on them separately. So let's break out of that, and so I'm going to make my tab component first. So that's the one, or the Renogy tab component first. It's going to sit in here instead of this static text. So I'm going to do a ng generate component. It's going to be called Renogy, and I'm going to use the option of skip tests. So there's my Renogy component now, the HTML, the TypeScript, and the style sheet for that component. So I want to replace this static text here with app. Looks good. And close that out. And at the moment, App Renogy's just got this Renogy works, so we should see that in our tab set now when I fire it up. that looks good. That's got our component text rather than the static text in there, so it's correctly bringing up the component when I go into that tab. So I'm going to work through the code here. I'm not going to do it in detail, but basically I'm going to sort of work backwards. I want to get the web service part working first. I want to call the Renogy status service first, because that's the easiest. Display that on the tab. Then I want to put the webcam on-off service in there, and then finally I'll put the Google Charts in to show the history for Renogy. So let's start working on that. I'll probably just show the end of each code section as I get it working. So let's show the code at this point. So far I created a service, and in the service I added a interface. So this is what defines what's coming back from the Renogy status web service. And otherwise I imported the httpClient, which is the Angular's way of getting to web services, and then I created a function called getStatus, and it returns a get on the Renogy status, which returns the Renogy status interface here, and has the URL. So later on I'll put all these things in parameters and probably add it to my environment information. So that's that's the service defined, and let's have a look at the Renogy component now. So I've added a bit more to the component now. So I've imported the Renogy service and the Renogy status parts of it's all in the Renogy service. So it's the interface and the actual class. So I create an observable or a variable to hold an observable of type Renogy status. In the constructor I pull in the Renogy service class, and then I make a variable, this Renogy status, which is an observable there, by calling the Renogy service getStatus. So that returns an observable after the call to the getStatus. So in the HTML I use the async pipe to query that observable and put it on the screen. First time I ran this, because I'm running from a different machine from what the web services are hosted on, I was getting a CORS error, cross domain error. So something I had to do, let me bring it up in that browser, and I've added it to the instructions for setting up the web side of things. So I added to the default.conf for Apache, I added this header there, which allows the cause type requests, and also to make sure that worked, I did a modification to Apache to allow it to support headers. So now it supports headers that allows requests on from other sites. So let's try running this. So I do an ng-serve just the same way, and that's going to compile the Angular code. And I'll go to Angular here, and here we see it's already working it. It's displaying the values it's got from the web service. So those are the current values out in the shed. I can still flip between the other tabs, come back to Renogy, it shows me the information, and let me see if I can, you can see you get some different values here. So it looks like every time you come into the tab, it does a refresh or does another call out to the web service to refresh it. So that's good. I need to add in the web service to turn on and off the webcam and the history graph and I'll probably burn through those. I'm also going to wrap this in some nicer looking Angular material stuff so the interface looks a lot better, and then we'll have a look at it after that. Yeah, this is about a week later. So I had a bit of a struggle with Angular. I hadn't used it for a couple of years, so I had to remember what I was doing there. But this is my interface, so again, it's pretty simple. So I'm just using the tabs up here to navigate around. At the moment, we're on the Renogy page, so now I've filled that in with all the details I want to show about the Renogy solar controller. So this is the current information off the controller, so it's showing the power that's coming in, the power that's going out, and I'm also now using Google Graphs to or Google Charts to show the history, and you can vary how many days history you want to see. So this is just 1 day's history, so we see the typical pattern of the battery draining overnight, and then as soon as the sun comes up in the morning, the battery getting up close to 100%. Here we see the power coming off the solar panels, and here we see the power going out, and really the big change is overnight the webcam's turned off, so you see the power draw dropping right down. We can swap to 7-day views, so we see the pattern day by day. You can see in here this was some cloudy days, so you see the battery power dropped a little bit because it wasn't getting enough charging from the solar panel. And I'm also going to include 30-day view and 1 year view. I think what I'll do for these ones too is I'll probably change it so that it comes back with the average for the day, or the totals for the day rather than for the hour. Once you get into 30 days and longer, it's probably best just to see the daily totals, because if you're looking at 30 days or even 1 year, you really just want to see, hey, what's happening over through different seasons and different weather conditions. The other thing I added here is in the rig, I've got a button to turn the rig on and off. So if it's off, like it is at the moment, and we can have a look in the settings here, we can say the ham rig's turned off. If I push the on button, it's now on, and if we look over here, we see the rig's now turned on. And I checked out in the shed that that's all working. And the other thing to look at is the settings. So the main settings, the parameters that drive this, you can now update here. So set the power save level, so this is the minimum power or in the battery that it gets to. So once it gets to 50%, then it starts turning things off, like won't run the webcam or the radio anymore, and it'll save as much power as it can. The webcam expiry minutes and the rig expiry minutes, so if I do turn one of these on and it's not on by default, then this is how long it'll stay off before it turns off again. Run the webcam at night, so if I want to force the webcam to run overnight, I can just change this from no to yes. And same thing for the webcam turn off time. I can set that to a value overnight, where instead of having the webcam run at night, I can have it turn off explicitly at a certain time. Press update to update those. So I think that's most of it, and like I said, I use material for a lot of this stuff, so it looks a bit better. And I can do things like look at it for different form factors. So say if I looked what it will look like on my iPhone SE, shows me things still fit in, collapses some of the layout a bit, but that's what I wanted, so that for things that aren't as wide, it just shows a single column rather than two columns. And then say on my iPad mini, it's a different view again. In this case, everything fits in, but just looks smaller on an iPad mini. So that's about it. I think I've got the Angular bit working. This is running off the actual Raspberry Pi out in the shed, so that's known as solar.home. So like I said, I put that in the top route of the Raspberry Pi's Apache setup, and I'll show at the end a little bit of how I was getting that done. And I'll have a look at some of the code. So really, I won't go through all the code. I'll just look at some of the important things, the things that held me up for a while, and things that are interesting, like the charting and some of the unique things I had to do to get this to work. Yeah, this is the highlights of the code. So I'll just show you the components I've put in now. So under app, we looked at Renogy before. So new ones are for the rig, that's the central tab, and settings, which is the tab on the far right. Also, I've got a services directory, so as well as having the Renogy services we looked at before, I've now got one for the cache web services, the rig web services. And I think that was a test one. I'll have to get rid of that one. Oh no, that's the webcam ones for turning on and off the webcams. So the relay ones. So let's have a look at first one. We'll have a look at Renogy. So that's been updated. So in the HTML here, so as before, I'm showing all the status information from the Renogy controller, but now I've got it wrapped in a grid wrapper, which allows it to change its layout depending on the width of the screen it's running on. Does a media query to do that. And then down here I've got another card which has the actual Google chart on it, and it's getting all its information off variables that are in the TypeScript file behind this. And you can see the radio buttons here. Again, I'm using material for that to show the 4 radio buttons, and then finally I have a button here that appears if the current status of the webcam is false, then I'll show the button to allow you to turn the webcam on. But I'll show you the working of this over in the rig. It's kind of a simpler page. And let's look at the TypeScript. So most of this I'll blow through, but interesting one here is chart options. So like I said, this is read by the Google charts. Some of the interesting things here was I had to use a combo chart to be able to have dual y-axes, so have a left side and a right side axis, because I have different scales for the percentage battery available, and then for the actual amperage on the output in the solar panel. Something that caught me out for a while is when you're defining 2 axes, you got to use this v-axes keyword to describe the details of what each axes properties are. But if you just got one axis, then you use this v-axis, and it applies to all the axes. The other thing here is where you set up the series. So I've got my first series, which is the battery percentage, goes to the axes 0, and then the other 2 series, which is the output power and the solar power, goes to axes 1. I think that's most of it. I've got this history change, which is triggered by the radio buttons at the bottom. Remember, we have 1 day, 7 day, 30 day, 1 year histories available. So really it's just calling the Renogy history service with the value that's coming back from the radio button, and that's going to be 1, 7, 30 or 365 depending on what you clicked on. That comes back, and I have to subscribe to the resulting observable to bring the data in, and I have to do some conversion, so from JSON to JSON to get it into a format that chart data is expecting. So Google Charts is expecting data in a certain format, so that returns it in the right format by doing that double JSON conversion. And then I'm converting all the epoch dates that are in the first series in this data, chart data, to being JavaScript dates, so I can display things as dates and times on the chart. I don't have to do much else. So that's pretty much the Renogy tab. Like I said, there's the rig tab that hasn't got much on it, so at the moment it just checks the current status of the rig, so our ham rig relay. If it's not on, then it shows a button where I can turn it on. If it is on, then it shows a button where I can turn it off. This is a little different from the webcam button. The webcam button, the only thing you can do is turn it on, you can't turn it off. But that's calling these routines called under click, called off rig. And if we look at that, we see the 2 routines here, and these are just calling the cache service. calling the rig service for either rig off or rig on. And we can have a quick look at the rig service. So under services, if we look at rig, there's the two services that actually call the web services out on the Raspberry Pi. One thing you notice here, I'm using environment to define what the URL of the Solar host is, and we can find those down in environment here. So both for the production and the test environment, I've got the same thing in here where it's got the prefix that will get you to the correct host to turn things on and off. And the last one I want to look at is just settings. I'm not going to get into too much detail here because there's a fair bit of code, but for the HTML, this had the most formatting using material controls. So I'm using material form fields and input fields with validators to be able to input the right information, and I'm either using text input for some of them, or else I'm using drop downs where there's just specified values I want to show as choices, and then this bottom half is where I show the current status of the rig or the webcam, whether it's powered on or off, and it just does some fancy coloring there to change them from one to the other. And again, I won't get into a lot of Angular here, but I'm using Angular forms to create this form definition, which is going to be the fields that I want from the cache that I want to be able to modify. So this defines that form and sets up the validators for each of the forms. So this is where I can say, hey, this field has to be between a value of, in this case, 1 and 180, and other things to make sure that people can't enter the wrong things. And then when the update button is pressed on that that page, it'll go through for any controls that, well, first it'll check that everything's valid on the page, that no invalid values have been put in there. But if they're all valid data on the form, then I'll check each of the controls and see which controls have been touched, because I don't need to do any updates to ones that haven't been touched by a user. And I go through, and for the fields I have in the form, it'll check each one and calls cache service and the routine to update the various values. Got a little tricky down here on these ones where they use numbers or binary values, so I had to do some conversion from the values that were in the drop down select boxes, which is all in strings, to the proper data type to call these services with. So I think that's about it. I may make some minor changes to this as I go along and use it for a while, but I think it's working pretty well at the moment. It's good enough for what I'm using here. So last thing, I just wanted to show how I get this code up onto the Raspberry Pi, because there's an adventure as well. So main thing I do is I bring up a terminal, just break out of there, and I do a ng build. So this builds the code it needs in this dist folder. So first it clears out what's in there. So it's generating the application for distribution. There we go. So now in the dist folder under SolarUI, I've got the files I need to put up on the Apache server for someone to connect in and run this application from there. So what I normally do is, let's see if I can bring it up here. Let me connect into Solar. And so I'm going to go into my projects, SolarUI, go to that dist folder. So those are the files I need to bring over to the Raspberry Pi. So let me open up a file shared to the Raspberry Pi. So I think I showed this before, where I set up SMB shares on the Raspberry Pi. So now I'm looking into, on the Raspberry Pi, the SolarUI folder. So this is just to get the files up onto the Raspberry Pi. I don't run them from this location on the Raspberry Pi, but at least it gets it there. So now I've got the files up on the Raspberry Pi. Now I can go to my SSH interface, do a sudo su to be in there as root, and I'm just going to, okay, first command I want to run is this one here. So it just clears out everything that's already in the var www html directory, and I have to do this as root. It didn't seem to let anyone else do this. So now I've cleared out the current website up there under Apache. So that just copied the files over to that var www html folder from where I'd copied them up through the SMB share. So we should be ready to go. All the files are there. The main file is the index.html. So that's what Apache is going to serve up as the default file, and that gets the Angular application running on someone's browser. Yeah, this one just shows a screen capture from my iPhone, so I find it all does the same thing in Angular. You can go to the rig, to my settings, set things. So this is all good. I might actually add a swipe option in to be able to swipe between the tabs rather than just having to click on them. But that's about the only change I need to make. So one more change I made to the UI. So this one still looks much the same, but what I changed was on the history. So once I get past about 20 days of history, instead of showing hourly buckets, changes to daily buckets, and that's going to work a lot better once I get to these much longer histories, 90 days, 1 year and things, where I just see sort of trends from day to day. So instead of an hour's worth of watts from the solar panel or from the output, it now shows you the total day and shows the trend in percentage for the battery for each day as well. So I should be able to see seasonal changes a lot better this way. So that's about it for the solar specific stuff. The next videos are going to get into the ham radio interface part of it. So I need to do the same thing. Set up first the cat interface to the ham radio. I'm going to use hamlib for that. Get that working, get some web services around the functionality that I'm going to use out of hamlib, and then put together or add to the Angular interface for the ham radio specific stuff. That may take 1 or 2 videos, and then I'm going to have a look at being able to listen to the audio coming off the radio, send audio to it, so I can sort of do transmit and receive. And I'm not sure whether I'm going to be able to do that through the web interface or whether I'm going to need to make another little application to do the audio streaming. I'm not sure yet. I've got to work that out. And like I said in the checklist, final thing I'll do is some cleanup. So see where things are breaking, probably put more try and catch type things in the code, clean up the code a bit more and wrap it all up.